NASA lost contact with the spacecraft orbiting Mars. There was no explosion, no collision, and no dramatic failure captured on camera. One moment, the spacecraft was transmitting data normally, performing its routine science operations, and responding to commands from Earth. The next moment, it was completely silent. No emergency signal was sent. No recovery signal followed. Communication simply stopped. The spacecraft was called MAVEN, short for Mars Atmosphere and Volatile Evolution. It was not experimental and it was not a prototype. MAVEN had been operating successfully for years, sending back valuable data about Mars's atmosphere, solar-wind interactions, and charged particles surrounding the planet. It was considered stable, reliable, and well understood. Before contact was lost, telemetry showed normal behavior, power systems were within expected ranges, thermal systems were stable, communication hardware had no reported faults. There was no indication that MAVEN was approaching the end of its operational life. Engineers were not preparing for failure. This was not a spacecraft that was slowly dying. During a routine orbital pass, MAVEN moved behind Mars, temporarily blocking its direct line of sight with Earth. This happens regularly during every orbit. For a short time, communication drops. Then, as the spacecraft emerges from behind the planet, the signal returns. This sequence has occurred thousands of times without incident. Except this time, it didn't. When MAVEN emerged from behind Mars, the signal never came back. There was no handshake, no data stream, no response to commands, just silence. And silence in space operations is one of the most unsettling outcomes possible. On its own, the unexplained loss of a spacecraft would already raise questions. But what makes this situation deeply unsettling is what MAVEN had been doing shortly before it went silent, because MAVEN had recently been observing something unusual, something rare, something that did not originate in our solar system. That object was designated 3I Atlas. The name itself sounds clinical and ordinary, but what it represents is anything but. 3I Atlas is only the third confirmed interstellar object ever detected passing through our solar system. That alone makes it exceptional. Interstellar means that this object did not form around our sun. It did not originate in the Kuiper Belt. It did not come from the Oort cloud. It formed around another star entirely, far beyond our solar neighborhood, and traveled through interstellar space before entering our system. This distinction matters more than it sounds. Every object we have ever studied in detail formed under roughly the same conditions, same star, same radiation environment, same gravitational influences. Our models are built on those assumptions. 3I Atlas breaks them. 3I Atlas is also unusually large. Estimates suggest it may be several kilometers across, potentially much larger than previous interstellar visitors. Objects of this size entering our solar system from interstellar space should be extraordinarily rare. Yet, here it was, passing directly through the inner solar system. It is also moving extremely fast, too fast to be captured by the sun's gravity. This is not a stable orbit. This object is not bound to our star. It is on a hyperbolic trajectory, meaning it entered once and will leave forever. This kind of trajectory is important. A fly-through object does not linger. It does not slow down. It does not settle into predictable paths. It passes through quickly, interacting briefly with planets, spacecraft, and observation platforms before disappearing back into interstellar space. And yet, 3I Atlas passed through the inner solar system at a time when multiple planets, satellites, and observation systems were in place. It passed near Mars. It passed within range of instruments designed to study charged particles, plasma interactions, and atmospheric escape, including MAVEN. MAVEN was specifically designed to study how Mars interacts with the solar wind and energetic particles from space. It was well positioned to observe unusual ionized environments, and it did observe 3I Atlas, NASA has not stated that the loss of MAVEN and the observation of 3I Atlas are directly connected. Officially, they are treated as separate events, but engineering analysis does not rely on official statements. It relies on timing, environment, and cause and effect relationships. In engineering, correlation does not automatically mean causation, but correlation does demand explanation. When two rare events occur close together in time and space, engineers do not ignore the overlap. They investigate it. To understand why 3I Atlas raised alarms among scientists, we need to talk about behavior, specifically how objects like comets are supposed to behave when they approach the sun. When a natural comet approaches the sun, heat causes surface ice to sublimate. Gas and dust are released, forming jets and tails that are pushed away from the sun by solar radiation pressure. This behavior is consistent, predictable, and well documented. This is why comet tails always point away from the sun. The physics is straightforward. Energy comes from solar heating, material escapes, and radiation pressure pushes it outward. The process is chaotic and uneven, but the overall direction is clear. 3I Atlas did not behave this way. Observations showed sustained jets ejecting material toward the sun, not briefly, not accidentally. Sustained, directional activity that directly opposed solar radiation pressure. For material to be expelled in that direction, energy must be supplied. Passive solar heating alone cannot account for sustained sun-facing ejection over extended periods. This creates a serious physical problem. Natural sublimation is messy. It fluctuates as an object rotates. It spreads unevenly across the surface. It does not remain narrow, focused, and stable for long distances. It certainly does not maintain consistent direction, but the jets observed on 3I Atlas were tightly collimated. They held their shape. They maintained direction. They behaved less like random outgassing and more like controlled exhaust. In propulsion engineering, this kind of behavior resembles controlled mass expulsion. In simpler terms, it looks like thrust. That does not automatically mean artificial origin, but it does mean the natural explanation becomes increasingly strained. Thrust creates torque. When mass is expelled, an object should begin to spin, wobble, or tumble unless the forces are carefully balanced. Natural objects do not balance thrust. They react chaotically. 3I Atlas did not show signs of rapid tumbling or destabilization. Its motion remained stable. Its orientation did not degrade. That level of stability under acceleration raises serious questions. Maintaining stability under thrust requires balanced force vectors. Balanced force vectors require regulation. Regulation requires control. And control is not something we associate with natural debris. Now return to MAVEN. MAVEN observed this object using ultraviolet instruments designed to study ionized gases and charged particle interactions. These environments are exactly where electromagnetic interference becomes possible. Shortly after these observations, MAVEN failed. Spacecraft electronics are sensitive. Plasma interactions, charged particle environments, and electromagnetic disturbances can disrupt systems without causing visible damage. This does not imply intent. It does not require a weapon. It simply means that if 3I Atlas created an energetic environment, interference becomes a plausible engineering explanation, so the question becomes unavoidable. If 3I Atlas were technological in nature, would MAVEN's failure make sense? From an engineering perspective, yes, and that is deeply uncomfortable. And this is only the first layer of the problem, because when you examine the trajectory of 3I Atlas, the idea of randomness begins to collapse entirely. That's where we go next. Don't forget, subscribe and turn on notifications, because once we look at the path this object took, coincidence stops being a viable explanation. In the first part, we established that 3I Atlas behaves in ways that strain natural explanations, but behavior alone is not the strongest evidence. The strongest evidence comes from motion, from paths, from trajectories, because in space, Movement is never random. Every object entering a star system follows the rules of gravity. Those rules are precise, predictable, and unforgiving. When something deviates from what gravity alone should produce, engineers pay attention. 3I Atlas entered our solar system on what is known as a hyperbolic trajectory. This means it was never captured by the sun. It was never bound to our star. It entered once at high speed and will leave forever. Hyperbolic objects usually pass through quickly and at strange angles. They do not align neatly with planetary planes. They do not skim regions dense with planets, moons, satellites, and observation platforms. But 3I Atlas did exactly that. Its path aligned closely with the ecliptic plane, the same flat disk where all major planets orbit. That alignment alone dramatically reduces the odds of randomness. Even more strangely, it moved counter to the direction of planetary rotation. This is not how random debris typically enters a star system. This is not what engineers expect from natural interstellar objects. When engineers design reconnaissance missions, they deliberately choose trajectories that maximize observational opportunities. They align with planetary planes. They chain encounters. They minimize wasted motion while maximizing information. 3I Atlas passed near Mars, then near Venus, and its trajectory aligns closely with Jupiter's gravitational boundary, a region known as the Hill sphere, where gravitational interactions become complex and useful for trajectory changes. Natural debris does not do this. It does not hop from planet to planet. It does not thread gravitational needles. It does not pass through the most information-rich regions of a system by chance. At this point, probability becomes important. Not vague probability, mathematical probability. The odds of an object entering at this angle, in this plane, at this speed, and at this timing are extremely low. To accept randomness, you must accept that a rare interstellar object also happened to take an extraordinarily unlikely path through the inner solar system. Engineers are trained not to ignore that kind of coincidence. Trajectory is not the only problem. Chemistry matters, and the chemical signatures observed from 3I Atlas create additional strain on natural explanations. Spectroscopic analysis revealed unusually high levels of carbon dioxide output. This is not typical behavior for comets at the distances involved, especially not at sustained levels over time. Even more concerning was the detection of nickel. Nickel does not sublimate easily. It requires high temperatures. It does not behave like common cometary materials, such as water ice or carbon monoxide. Nickel is commonly used in engineered alloys because it resists heat, radiation, and structural stress. These are the same environments encountered by high-speed objects moving through space. Nature does not selectively refine materials. When unusual material ratios appear, it implies either extreme processing or conditions that are not easily explained by standard natural formation models. Energy is another unresolved problem. The observed activity of 3I Atlas exceeds what passive solar heating alone can explain, especially given its distance from the sun during peak activity. Natural comets become dormant as they move away from the sun. Their activity fades, jets weaken, surfaces cool. 3I Atlas did not follow this pattern. This raises a difficult question. Where did the energy come from? Without an internal energy source, the observed behavior becomes increasingly difficult to explain. Now return once again to Maven. Maven was observing ionized environments, plasma interactions, and charged particle behavior around Mars when it encountered 3I Atlas. Shortly after those observations, Maven failed. Spacecraft electronics are vulnerable to electromagnetic interference, plasma interactions, and charging events that leave no visible physical damage. This does not imply intent. It does not imply hostility. It implies proximity to an energetic environment capable of disrupting sensitive systems. If 3i Atlas were technological in nature, such interference would not be surprising. Advanced propulsion environments naturally produce electromagnetic and plasma effects. To believe all of this is purely natural, you must accept multiple unlikely explanations simultaneously. Unlikely behavior, unlikely trajectories, unlikely chemistry, unlikely timing. At some point, stacking improbabilities stops being scientific skepticism and starts becoming denial. Engineers are trained to recognize that moment. This does not prove alien origin, but it creates a problem that natural explanations struggle to resolve without invoking increasingly complex assumptions. Something passed through our solar system that does not fit neatly into any known category. It observed, it interacted, and then it left. Whatever 3i Atlas truly was, it forces us to confront the limits of our assumptions about what can and cannot move through our cosmic neighborhood. Before we end, there's something important I want to talk about. While we spend time questioning what may be moving through space, there are lives here on Earth suffering right now. Dogs are living outside in freezing temperatures. No shelter, no warmth. Some are abandoned, some are neglected. Many are clinging to life through cold nights. Almost home canine rescue steps in where no one else does. They pull dogs out of abuse, neglect, and freezing conditions, often just in time. Rescue costs money, emergency vet care, food, heat, safe foster homes. Without donations, dogs are left behind. If you're able to help, please consider donating. The link to Almost Home Canine Rescue is in the description below. Even a small amount can mean warmth, safety, and another day alive. This is Paul from Shed Show Talk. Thank you for watching and thank you for caring. Stay safe and keep your eye on the sky, because lately it feels like the sky might be watching back. If you want to stay updated on stories like this, subscribe and turn on notifications. This conversation isn't over.